Hello everyone, this is Dr. Hall. Welcome today to these lectures of biomechanics. And this is the topic of chapter 4 of the ACSM, the American College of Sport Medicine, Resources for Personal Trainer. The official book use it as a part of the study materials for the Certified Personal Trainer, the CPT, or the Certified Exercise Physiologist offer this certification are offered for the American College of Sport Medicine. And about the topic about biomechanics, we will cover various topics of this chapter, but let's introduce and define this important concept and what exactly is biomechanics. Simply put, biomechanics refers to the mechanics by which the components of the body interact to produce movement. It's very easy. It's actually quite straightforward. Bio means life, and mechanics refers machines. So you can think of it as the machine of life. Our goal is to understand how the human body functions as a machine from two key perspectives, kinetic and kinematic. Kinetic deals with the forces the body encounters and produces, and kinematic focus on the resulting movement of the body in space. So for this, I have the help of my past students. We make a team in the past about this topic. My former students, Miguel Sandoval and Aileen Castro, both are kinesiology students. Miguel has been a basketball player for 10 years and is starting in elementary school, and Aileen has been a triathlete for 6 years. So they do strength exercise, and they try to understand these concepts in their training, and obviously when they had the chance, the opportunity in the future to attend their clients. But well, the first topic is to analyze classification. This is a classification system for determine muscles action during a movement, and identify. Basically, we need to, as you can observe over there, muscle on the screen, identify how muscle acts as agonist, antagonist, synergist, and stabilizers. While performing an exercise, you can find the definition on the screen, and also in our page in our book, in the previous chapters about muscles and kinesiology, you have more information about this concept. But we are going to put some examples with some videos of these biomechanical principles in a fitness facility. And in here, basically, we can observe these classic examples of this concept about agonist, antagonist, synergist, and stabilizer. When you perform this exercise, the bicep muscles cause the movement by flexing the elbow. In this case, we refer to the biceps as the agonist, as it is directly responsible for bringing about the movement. The antagonist is the muscle that oppose or resist the movement. In the bicep curl, in this exercise, the triceps act as the antagonist because it is the capability to slow down or stop the flexion of the elbow. Now we're going to move to the synergist. In this muscle that assists indirectly the movement, the bicep curl is the pronator teres is an example of a synergist, as it is help with a pronation at the radial ulnar joint, And finally, the stabilizer muscles in a bicep curl are small muscles of the upper back connected to the scapula, such as the rhomboid minor and major, and these muscles helps stabilize the shoulder, allowing for proper movement and this in the distal segment during the exercise, whether the scapula is in retraction, protraction, or upward rotation. And we can analyze in here the example of this exercise. The agonists are the bicep brachii, antagonists, triceps, synergies are the teres, pronator teres, and the rhomboid minor and major are the stabilizer. So let's check now in here another example. We can identify muscle action classification, agonists, antagonists, synergies, stabilizers in different exercises. We're going to put another exercise that is very typically is another example. This is the squat. So in here in the squat, we can observe the exercise in here. The agonists are the quadriceps and the gluteus muscles. The quadriceps are responsible for extending the knee, while the gluteus muscles helps with extension as you rise from the squat position. And the antagonist muscles of this exercise are the hamstring and the hip flexors. These muscles oppose the movement by resisting knee extension and hip flexion, helping to slow down and control the descent during the squat. We have the synergist muscle too in the squat. Include muscles like abductors and the calves. The abductors assist in stabilizing legs, while calves helps with the ankle stability, ensuring proper posture and movement through the full range of the squat. And finally, the stabilizer muscle are in the core. This exercise provide stabilization through the core muscles, including rectus abdominis and rectus spine, and these muscles helps basically stabilize the spine, stabilize the pelvis, maintaining proper posture, preventing injury through the squat movements. And in here we are going to connect this information. This is the knowledge share for today. Involves a task, basically some concepts that we're going to analyze of biomechanics and the agonists, antagonists, synergies, and stabilizers muscles. Also, you need to connect with an arrow the kinetic action of the bicep curl and the squat exercise with the correct muscles that involve the action of agonist or antagonist or synergist, depending of this. And as a homework, you have this challenge. It's not complicated. It's just the next steps is involves in here critical thinking for your assignment for your homework. You will research how these kinematic concepts applied, but with another typical exercise. This is the bench press. It's another exercise, and then you are going to select another exercise of your choice, two exercise, bench press, another one, and be sure to identify this role of exercise. The agonist, the muscle most directly involved in bringing about the movement, also called prima mover. Antagonist, muscle that can slow down and stop movement. Synergies, muscle that assist indirectly in a movement. And finally, stabilizers, muscle that contribute to the joint stiffness by co-contracting and show an early onset activation in response to perturbation. So, other important concept in here in our chapter of biomechanics is explain how is important the components of a lever, for example, because when you are asking a client to perform certain lift, it is help to understand what type of levers you are asking them to use. There are three class of levers then we are going to analyze, and the book focus is the class, the first class, the second class, and the third class. But basically, many muscles in the body do not act through levers, but body movements directly involved in a sport and exercise primarily act through the bony lever of the skeleton. And a lever is a rigid or semi-rigid when subject to a force whose line of action does not pass through its pivot point, except for any object impeding its tendency. So we are going to analyze this one in here. The class, the first class lever, the second class lever, and the third class lever. And we're going to put some examples of human body examples. The first is going to be the pivot point or fulcrum is located between the force and the resistance. The lever system in here is rarely found in the human body, but an example of this is between the head and the first vertebra. In this case, the mass or resistance is the head, and the fulcrum in this point is the atlo-occipital joint. Of the force comes from the posterior muscles such as the trapezius. We have another example in here. This you're going to find it in the exam. And here we have the team Castro Sandoval performing this exercise. Identified that this is the first class lever, is the elbow extension against resistance in the exercise of triceps push down. Now we are going to go for the second, and this class of lever has both of the forces and resistance on the same side of the fulcrum, with the force being farther from the pivot point. In calf raises, the triceps sure are contracted to move the center of mass vertically, while the client body weights is between the insertion of the triceps sure, the calcaneal tendon, and the foot fur. So in here we had the example. So we had the plantar flexion against resistance. So standing dumbbell calf rise is the example that we can find in here. The number three kind of lever, we have this one in here. Then basically is this is the most this class, the third class, is the most commonly associated with free weights. In this case, the resistance and the force are both on the same side of fulcrum. We have an example over there of bicep curl exercise, but the resistance is farther from the pivot than the force For example, during the bicep curl, the weight will be in the client hand, and the biceps are contracting and pulling on their insertion in the radial tuberosity and causing rotation about the elbow. Most muscles in the body are third class levers, and therefore they they perform movements at a mechanical disadvantage. More about this, uh, we have the example here in the team. We can see the elbow flexion against the resistance, the bicep curl in the bicep curl exercise. And now we're going to go to other concept that is involved in this important reference, and this is the force length relationship. And the force length relationship, it described how the force muscle can generate change depending on its length. We can observe the figure 4.7 over there in the screen. A muscle produce the most force when they are at the optimal length, typically near their resting length. A muscle is stretched too far, uh, lengthened below the optimal point, or contracted too much, shortened beyond the optimal point. Its ability to generate forces decrease. This relation is crucial to understand muscle proper during different movements, and as it influences how effectively can generate force at various joint angles. Another example in here than the this chapter of biomechanics of the book ACSM Resources of Personal Trainer has is the force velocity relationship. And force velocity relationship refers to the inverse relationship between the force muscles can generate and the velocity contraction. When a muscle contracts a higher velocity, faster movements, it generates less force. Conversely, when the muscle contracts lower velocity, it can generate more force. This relationship is important to understand how muscles perform during different types of movements. So whether they are focused on strength, like low velocity, or speed, or like high velocity. Other important topic of this chapter, the chapter number 4 of this book, is about biomechanics of selected movements. Are some examples in here. Band one typically that we can find is the proper technique of lifting object. You have an example of it there, proper and improper technique, but basically here to lift object safely off the floor and prevent an injury is important, is essential. Follow this proper technique, like stand close to the object, like bend at the hips and knees on the back, like grip the object firmly, lift with your legs, and keep the object close to you. Avoid also twisting and stay tall, and keep your head up is important. Another example of the book is a basic movement that we have, like walking gait. We have the different stages of the stack leg and the stride leg. So we need to identify the stance phase and the swim phase for a walking gait. And well, it it's important, this lecture, and it's important covering this topic of biomechanics of chapter 4, the ACSM of this book, because for a personal trainer, the consideration about the exam and knowledge in their practical application about the science of personal trainer is very important for develop a proper function. So this was the biomechanic topic.